Okay, welcome back. Another term, more screencasts. Okay, sorry that I forgot to go through and forgot to assign worksheet 9 and worksheet 10. So let me just go through it very quickly here. So here's the MCQ answers. Please note down your answers. Now, question 1. This is the Haber process. Ammonia is formed by reacting nitrogen and hydrogen together. So a high yield is favored with high pressure, low temperature. However, we use a high temperature in practice, 500 degrees Celsius, because at low temperature, reaction rates are too slow. So actually this is already explained in class. It is always between yield versus rate of reaction. Preferably, we want yield to be high and rate of reaction to be fast. Okay, we want these two to be high, but sometimes they contradict one another. So we need to look for compromise. Rate of reaction cannot be too slow, if not, it's not feasible. We don't want to wait for like days or even years just to make sure that the yield is high. Okay, that is still not productive. So answer is A. Question 2, when system is at equilibrium. Okay, so the word equilibrium, you must know what it means. Equilibrium is when the rate of forward reaction is equivalent to the rate of backwards reaction. Hence, we will see that the concentration of A, B, C, D will remain about constant. If I were to draw a graph, it will look like this. Let's say A, at first is a reactant, start off with high concentration, but as it reaches equilibrium, it will start to plateau. Okay, even though it plateaus, it doesn't mean that A is not being used up to form C and D anymore, or C and D does not form A anymore, but rather the rate that it does so is the same. Therefore, we do not see, on average, a change in the concentration of A at equilibrium anymore. So this is the time it takes to establish the equilibrium. Okay, and maybe like C started off with 0 and then it will to become this. So maybe C, I don't know. Okay, so answer will be D. Neither the forward nor the reverse reaction has stopped. They are both continuing, just that they are at the same rate. Question 3. Consider the gas phase equilibrium given that delta H is positive. So we know a few information. We know that these are gas. So a possible factor is pressure. And then delta H is positive. So another factor is temperature. Now, if delta H is positive, which of the following changes will decrease? If I want this to decrease, H2O to decrease, I must want to favor the right-hand side. I want to favor the right-hand side. So to favor the right-hand side, first let's observe the number of moles of gases. Over here, I have 2 moles of gases. Here, I have 3. So if I want to favor the right-hand side, favor the side with more number of moles of gas, the change I need to make will have to be to decrease the pressure. Okay, to decrease the pressure, I can increase the volume of the container. So A is decreasing the volume, which means I'm increasing pressure. So A is out. Okay, given that delta H is positive, if delta H is positive, what kind of reaction is this? Delta H is positive, it means that it is endothermic. Okay, now if it's endothermic, it means that it takes in energy, takes in heat. Okay, when I increase temperature, to counter the increase in temperature, I must favor the reaction that takes in the excess heat. So it does help to favor the right-hand side. So answer is B. Is it? Yes. Question 4. Consider the reaction at equilibrium at 1000 degrees Celsius. I have carbon monoxide reacting with oxygen to give carbon dioxide. Which of the change will result in a lower yield of CO2? This is very standard again. So we want, if this is to be decreased, it means it favors this the backwards reaction instead. So what kind of condition will favor the backward reaction? Again, they are all gaseous, so pressure is a factor, and they give you delta H, so you know temperature is a factor. Okay, so on the left hand side there is 3 mole, right hand side 2 mole. This is negative, so this is exothermic. The forward reaction is exothermic. Okay, so which change will result in a lower yield? I want to favor the backward reaction. I want to favor the side with more number of moles of gas. So it means that pressure should be decreased such that I want to create more number of moles of gas to make pressure higher. Now, I want to favor the backwards reaction, which means it's also forward is exothermic, backwards is endothermic. So if I want to favor the reaction that takes in heat, I must first increase temperature. Okay, which change would result in a lower yield? So which one decrease the pressure? A. So answer is A. Okay, I decrease the pressure by increasing the volume. Then if I increase the volume, decreasing the pressure, that's a change. To counter the change, the Chapter's principle states that it will favor the side with a greater number of moles of gas. So it favors the left-hand side. Okay. Adding a catalyst, remember, adding a catalyst does not affect you because catalyst increases the rate of reaction of both forward and backward reaction by the same extent. Okay, question 5. An experiment is carried out to investigate the effect of temperature change on the reaction by this. What will be the result if temperature increases? Okay, if temperature increases, and let's look at delta H. Delta H is positive, so this is endothermic, which means it takes in heat. Okay, when temperature increases, to counter this change, this increase in temperature, I will want to take in heat, favor the side that takes in the heat, which means I'm favoring the endothermic reaction. Therefore, I'm favoring the forward reaction. Okay, so if you read the options, the position of equilibrium will shift to the right. So D is correct. And why will equilibrium be reached more quickly? Now, that's because when temperature increases, the rate of collision, effective collision also increases for both directions. Okay, so not only is the forward reaction faster, the backward reaction is also faster, and hence it establishes equilibrium much more quickly. Question 6. Consider the equilibrium system. Which of the following changes will not lead to an increase in the total amount of CO2? So you do not want it to favor this direction. Do not. Okay, so let's read the options. A. Decreasing the volume. So if I decrease the volume, how is pressure changed? When volume is decreased, becoming smaller, pressure is increased. When pressure is increased, it will favor the side with less number of gaseous molecule. Okay, so if we look at the state symbol, solid, solid, gas, the side with lesser number of gaseous molecule will be your left-hand side. So it will not lead to an increase in the total amount of chlorine, but instead it will decrease the total amount of chlorine gas that's produced. So answer is A. Question 7. Which of the following is a correct statement about the effect of a catalyst on a reversible reaction? A. It increases the rate of the forward reaction only. Now this is not true because as we state, if initially the rate of forward reaction and the backward reaction is like this, a catalyst achieves both reactions faster. Okay, so both forward and backward reaction is faster. So A and B are both wrong. C, it provides an alternative route for the reaction. C is correct because originally, the original route is like this, with the activation energy being like this, but with a catalyst, it provides an alternative pathway such that the EA is smaller. So answer is C. D is wrong again because it doesn't affect U. Question 8. When chloride ions are added to the solution containing cobalt, the following equilibrium is established. This is what we did in the practical. Solutions containing that cobalt-2 as well as chloride are frequently violet in color owing to the presence of both the pink one and the blue one. Which of the following statements concerning such solution is true? A. Diluting the solution with water will make the solution turn blue. Now, if I add more water here, the concentration of water increases. To counteract this change, the system will try to use out the increase in water by favoring the backwards reaction. So instead of it turning blue, it should turn pink instead. B. If the reaction is endothermic, so if this reaction is endothermic, cooling the reaction will make the color turn pink. Okay, so cooling the solution by decreased temperature, it should favor side that release heat, which means it will favor the exothermic reaction. If the forward reaction is endothermic, this means that it favors the backwards reaction, which makes it pink. So answer is B. Let's just look at the other options to be clear. C, if the reaction is exothermic, heating the solution will make the color turn blue. Okay, if the reaction is exothermic, heating the temperature, increasing temperature will make it favor side that absorbs heat to counter the change. So it should favor the endothermic reaction, which is also backwards and also pink. Therefore, C is wrong. Adding a large amount of solid NaCl to the solution will make the color turn pink. Now, when we add solid NaCl, it will dissolve, right, and give us more chloride ions. When this increased, it will shift towards the right and the color will turn blue. Question 9 and 10 refers to the following reaction, and equilibrium can be represented by the following equation. P plus Q gives us 2R plus S. Okay, in a certain mixture, the equilibrium concentration of Q is 10 mole per dm cube. What will be the new equilibrium concentration of Q if 5 additional moles of pure Q is dissolved in 1 dm cube of the mixture? Okay, so to do this, I always like to draw some small table. P, Q, R, S. Okay, initially this is 10. If I add 5 additional mole, what will happen? Now when this concentration is increased, it will shift right such that I will try and use up some of the increase in concentration of Q. Hence, it will not be 15 because some of it will be used up. It will not be 10 also because if it goes back to exactly how it was previously, it means that this side there is too much of an increase. You want to kind of balance the increase to make it a new equilibrium. Hence, the answer will be B. You are using up some of the increase, but not all. Okay, so actually you don't need to draw a table for this. Oh, I thought it's going to calculate like R and S. Okay, which of the following changes will have an effect on the position of equilibrium? A. Adding a catalyst. Wrong. Catalyst does not affect equilibrium position. B. Adding water to the reaction container. Okay, if you add water, since water is not a reactant here, it's just a solvent. And if I add water to the reaction container, I'm diluting everything to the same extent. So it also does not affect the equilibrium position. C. Removing P from the reaction container. Now if I remove this totally, equilibrium will shift towards the left to try and replenish the loss in P. So it does have an effect on the position of equilibrium. D. Increasing atmospheric pressure. Now, none of them are gaseous, so pressure is not a factor. So answer is C. Oh no. Okay, so that's all for this worksheet 9. I'll see you in worksheet 10.